And without further ado, it is my pleasure to introduce to you the first speaker. Danny is a 30-year-old software engineer with experience in containerization, Java. Java, really? Okay. I used to do Java, but my therapist says I don't have to talk about that anymore. No, Java, PHP, TypeScript, and other JavaScripty stuff. His passion is microservice-oriented architecture, but somehow he keeps finding himself throwing front ends together in the process. Danny, I can tell you how to stop that, okay? Do like I do and suck at front end. If you're bad enough, people stop asking you to do them. Without further ado, please allow me to introduce Danny Verpoort. And I hope I pronounced that right, Danny.
Yeah, you did. Thank you very much for the introduction, Cal. And let's get into it. Because today I want to tell you something about using API contracts for testing and development. Cal already mentioned a little bit about myself. I'm a full-time software engineer, and currently I'm at work at Bauwatch, where we have state-of-the-art temporary surveillance systems. They're equipped with high-quality CCTV towers, and they have security alarms which handle anti-theft and construction site safety. When I'm not at work, I am a lifeguard. I train the lifeguards here in my hometown of Enschede, and I help them to keep the beaches in the Netherlands safe during the summertime. Ironically, I am very allergic to cats, and you will all find out a little bit later why that is so ironic. But let me get started with the divide between front-end and back-end. I'm into a bit of both worlds. I do Java backends, but I also write frontends. And they would interact through some sort of APIs. And in a lot of companies, you see that there's one team writing the API or the microservices, and then there is another team that maintains your front ends. And that can sometimes lead to confusion when the backend introduces a new change and the front end wasn't quite ready for that. So they have to adapt quickly, and that might also be able to break your front end. And to be honest, I like to be quite a lazy developer. I hope you all are, because that generally means you end up with the most efficient solution. And the picture you see to the right of the slide is called the lazy river. And the lazy river is just a flow of water where you slide on a tube. You just sit back and relax. And that's basically the goal of what we're doing today. What I want to do with you together is generate an API client package from our backend. So we have an API, and that API can generate a client which you can implement in your front end, so you don't have to write all of your API code in the process. We are going to use GitLab pipelines to publish that package to the GitLab Composer repository. And then we'll install the API client in our front end and automate the tests so that when the backend changes, we can also test our front end to see if it works. And then we can profit from all of those steps. Because we have more quality, we have to write less code, which is, in my opinion, awesome. So let's have a look at what our use case is. I'm recently married, just over 2 months ago, and my wife absolutely adores cats. But that's kind of where the irony comes in when I mentioned in the first slide that I'm allergic to cats. Because, well, it wouldn't be a good idea for us to adopt a cat because I'd be sneezing all day. So what I want to do is I want to generate a web page which has information about cats. And so we can pick a cat that would fit best for my allergies. Because to be honest, I still do love cats and I would like to adopt one. So this is what that would look like. there is a cats API, which has public information available about different breeds of cats, and that API is created by that API company. What I did is I took their API documentation and I wrote a spec for that. And from that spec, I will generate the API client package. I will make the API calls to that public API in my front end. And I will write a test for the front end to detect any breaking changes from the backend. So what I used to do that is the OpenAPI specification. On the right of the slide, you see a Swagger UI representation of our API. It has a nice picture on top, which was done with some markdown. And then it has the different endpoints below there. So we have the breeds and the image endpoints. There's a lot more to that API, but for today, these are the important endpoints that I have. So we'll stick to those. Now, there's two ways that you can write that specification, through YAML or through JSON. And I'm sorry, I'm more of a YAML guy. To all of you that prefer JSON, I'm sorry, it's an option, but today we'll be doing YAML. There's a couple of definitions you can write. There's models that define how your content of your requests look like and the content of the responses. You can define authentication and authorization types. So for example, if your API uses an OAuth authorization flow, you can have that in here. You can write some general documentation, and you can do a lot more with OpenAPI. I just highlighted some of the things that we need today. So let's dive into the spec that I created for these cats. And this is the first part. We start off by defining our OpenAPI version, and then we have an info block. And that info block contains some metadata about our API. So it has a title, it has some sort of Semver versioning, and then a description which can be written in Markdown. So that's our first block. Then the second block is called tags, and the tags allow us to categorize our API. So if we look back at the Swagger UI that we saw before, there was two types of categories, one being breed and one being images, and we can write a bit of a description about those different categories. The next part is basically the models, or the way the requests and the response could look like, the content of those. And you see a block called components, then schema, and then breed. And when we are talking about breeds, we have an object which has several properties. And in this case, that property could be, for example, dog friendly, which is basically a rating, an integer rating with a minimum of 1 and a maximum of 5. And if we wanted to use that in our front end, we could have a UI which shows like a star rating with different colored stars and gray stars, depending on what the min and the max is. Then there's a description, which is basically a text. And then we can have Booleans like hairless, for example. And that would be something I would be looking for when I'm searching for the right cat. We could also add allergy friendly as a rating in here with a minimum and a maximum of 5. There's lots of different options we can do here. Then we have our actual requests and responses, and this is what that would look like. We have a breeds section in our API, and then we can get a specific breed by passing in the breed ID. It's a get operation. You could do different kinds of operations. You could do posts, put, deletes, etc. And then we have an operation ID. And that operation ID we'll see a little bit later in the presentation, because when I generate a package from this OpenAPI specification, that's the method name that we would get from the package. Then you see the tags again, which means that this endpoint is contained within the breeds category. And then we see a parameter, which in our case is a breed ID. It's within the path. We could also pass in query parameters, for example, here. And we indicated that it's required, because if we don't pass in the breed ID, we would get the breeds endpoint, which would give us a list of all of the different breeds. Then we have the responses. I just picked a sample. This is a 200 response with the description OK. And we can have different content types. So in my case, that would be application JSON. But if you wanted to do XML, that would also be an option. Then there's a schema which references the model that we defined earlier. So here you see the components /schemas /breed. And if I look back at the previous slide, that same structure is present there. Now, had this been an in-person conference, I would have asked you all to show a raise of hands who had learned about Swagger already. But Swagger is the tool set which you can use with the OpenAPI specification. A lot of you would think that I'm talking about the Swagger specs, but it's the OpenAPI specification, and Swagger is the tool set that belongs to that specification. And today we will make use of that tool set. We have the Swagger UI here, which is the package that created the documentation page that I showed you earlier. And the second tool we will be using is the OpenAPI generator command line interface. And this is the actual package that does most of the work for us, because this is the package that takes our specification and transfers it into a library we can use. There's lots of different options for languages. So if you, for example, have an API written in PHP, you could also generate these different types of packages in different types of languages to provide them to your users. In this case, we're looking for the PHP client, but there's lots of more options. And this isn't even all of it, because, for example, if I take the TypeScript client, the TypeScript client is also subdivided into different request response packages. There are several popular ones, and you can use those in your projects as well. Now, we can't just generate clients. We also have an option to generate a server stub. So I wouldn't do this in a company environment, because most companies would have a boilerplate you would get started from, which contains, for example, some tooling for logging, authorization, secret management, etc. So this might not be suitable for my day-to-day work. But what I can use it for is if I have a simple project that I would like to do at home, I can take the OpenAPI specification, write a spec of what I want the API to look like, and then generate a server stub from that. And that server stub would allow me to bootstrap a project more quickly, which is awesome. Now let's get down to the meat of it, because I want to show you bits of example of how I built the application. At the end of my presentation, there's a link to the GitLab repository where you can see the code in action and check it out for yourself, because I did leave out a thing or two here and there to not make it too complex for this presentation. Otherwise, we would probably be sitting here until the afternoon, and we wouldn't want that. We have more cool speakers lined up. So let's get down to it. And for the development environment, I chose to use containerization, which always solves awesome problems, but can be a headache sometimes. But in this case, it worked out pretty well. So let me show you the structure first. To the right, you'll see my actual IDE. And to the left, you'll see the client that we use to connect to our environment. What I did is I added a Docker Compose file to the project, and that Docker Compose file defines some containers. You see the Nginx container to the left, which has different endpoints. It has a client endpoint, a Swagger UI endpoint, and a server endpoint. So from bottom to top, the server, anything that starts with, for example, localhost /API would be handled by the server container. Anything that starts with /API docs would be handled by the Swagger UI container. And then last but not least, anything else would be handled by our front-end container. Now, there's a total of 4 containers in action here with 3 different volumes. Those volumes are synced between my computer, so the actual host, and the Docker containers. So let's start bottom up again. We have a spec volume, and that spec volume is where we can put our OpenAPI YAML file. That file is then synced into the server, which allows us to publish the server and redirect calls. In this case, for example, what I did is I created a simple proxy, which redirects the calls directly to the production API of the cat API. Then the YAML file is also synced to the Swagger UI container. And what the Swagger UI container does is it takes the OpenAPI specification and it creates a web page showing the documentation of that API. So while you're developing your front end, you can use the client package, but you also have the documentation for the API available to you. Then there's the next container, which is the API generator, and that's linked up to the package volume. That package volume is the actual volume that contains our PHP API client package. And that's synced into the front-end container so that we can use it there to make API calls to our backend. Then there's also a package volume. The package volume is also synced between our computer, between our host and the container, because we want to be able to use our IDE for code completion. If we didn't have that volume to sync it back to the host, we wouldn't be able to have that code in our IDE, it wouldn't recognize it, and we wouldn't be able to have code completion. Then there's the front-end container, and in this case, in this project, I created a Laravel project in the front end, which uses Twig, and then that Twig template renders out all the different cats. And this is what that Docker Compose specification would look like. We start off with the OpenAPI container, which runs on an image called Swagger API-Swagger UI, and we set a couple of environment variables. The first one being the actual location of the OpenAPI spec. So we sync it in with a volume, which is defined below. And then we can point the Swagger image to the right API file. The layout, base layout, basically means that when we have the UI generated, we won't have the top bar. The top bar contains, for example, a drop-down to different projects, and we wouldn't need that here. Then the base URL, like I mentioned before, it all runs on API docs, and that's where you can see the documentation once the container is up. Then there's the package container, and that uses the OpenAPI generator CLI, and it uses the command generate. It takes an argument -i, which is the input, which is basically our OpenAPI file. Then it takes the argument -g, which is the type of generator you would use. In our case, it would be PHP, but you can also do, for example, TypeScript or any other generators that we saw in the earlier slides. Then we have an O argument, which is the output, and we have a minimum update argument, which means that we don't regenerate the client every time the OpenAPI spec changes. That would slow our development process down by too much. Then there is further parameters, -p, which has the composer package name, which is the package name under which you would publish your composer package. Then the second package name and the invoker package is the namespace in which our API files are generated. Then there's the volumes, and we do a restart unless stopped. And that means that we have everything to get going, to use our package, and to write an awesome front end. There's one small thing that I need to do in our front end. Like I mentioned before, I'm using Laravel, and Laravel has a dependency injection container. Because what I want to do is that every time that I load up one of the API classes, I want to provision it with the right host. So in this case, there's an app service provider, and that app service provider allows me to bootstrap a certain class, or if I request an interface, give back the right concrete class. So in this case, I'm using that to set the host. I create a new client, I create a new configuration, and in that configuration, I set the correct host, which I take from my environment file or my environment set in some machine. Then I load up all of the API classes, which I do by using the class finder package. And then I take all of the classes which are defined within the API namespace. And for each of that class, I bind the configuration into the API class, and that means I'm ready and set to use them. And then this is all of the code that remains to use the API. So in this case, I have a route at /, which is our homepage. I pass in the breeds API through dependency injection. And then what I do is I start with an empty array of breeds. And what I noticed is that the API does not have an image for every different type of breed. So I had to figure out some way to pass in a fallback image. So in this case, it's a placeholder image, which is basically 200 by 200 with a text no image. Then all I need to do is within a try block, do breeds API get breeds. And that get breeds function we defined by adding an operation ID to our API spec earlier. Now, there is a possibility that we run into a 404 or a 500 or many different types of errors, and those errors can be handled within the catch part of our code. It generates a catch API exception, and that would allow us to show the user feedback depending on different types of errors. And then all I need to do is return the view, pass in the right breeds, pass in the fallback image, and bam, that's why we end up with our cats page. This is basically a page which contains the name of the breeds, a small description, a nice image, and a link to the Wikipedia page where we can get some further information. But now we're just stuck in development. We also want to be able to publish the package so that other people may use it. You can imagine if I wanted to write an app, it would be cool if there's already an API package available that I can use. So what I want to do is I want to take the pipeline and serve the package right through there. And to be able to do that, I'm going to use GitLab and define different pipeline jobs. And what I'm going to do is I'm going to use a downstream pipeline feature in GitLab, which allows me to do different types of pipelines in different registries. So this is the way that my project is split up. I have an API repository, and that API repository contains our spec and the code for the API. And what I want to do is every time that my OpenAPI file changes in a merge request, or if I tag a new version of the API, I want to start a downstream pipeline in a different project so that we can generate that API spec and publish the right client package. Once we've done that inside the package repository, we can move on to the front-end repository. And in the front-end repository, we want to be able to do some unit testing. So that means every time that my OpenAPI spec changes, we can also test the front end to validate if those changes are going to break anything. And here's what that first part looks like. So we want to trigger a downstream pipeline. I have a pipeline job that's called build client, and I put that in the stage build. In this stage, I could also, for example, build my Docker image so that I can publish it somewhere and run it through Kubernetes or Mesos or any other type of container management. Then there's a trigger keyword, and that trigger keyword is what actually allows a downstream project to run. I target the Danny Talks / API contract client packages repository, and I target the main branch. And then I use a strategy depend. And what the difference is between using strategy depend or leaving it out entirely is that if I leave it out, the pipeline job is going to run here in the client, in the API repository, and it won't halt the rest of the pipeline if it fails. So it's just going to spawn the downstream pipeline, and it's going to continue on its merry way, even if the downstream pipeline fails. Now, in this case, I did add strategy depend, and that would mean that I'm using the downstream package as an actual pipeline job within the upstream. So if the downstream fails, the upstream fails as well. Now in the diagram just now, we said that we only want to do this when we're building new tags or when we have a merge request, and that merge request needs to contain the changes to the OpenAPI YAML file. But then I ran into a little problem, because if I look at the GitLab specification, we have a trigger job defined, and there's a couple of keywords that we can use. We can use trigger, allow failure, when, extend, but the only thing I'm missing here is the artifacts keyword. I am not allowed to publish artifacts within this pipeline step. So I had to find a way around that, because I do need to get the OpenAPI file from our API package into the package repository. So here's what that would look like. I defined a new step, which is called export OpenAPI, and I did that in the pre-stage. The pre-stage is one of the predefined stages by GitLab you can use, and I added a little script to it. It doesn't do much. It just exports the job ID. And in this case, we have a CI job ID, which is a variable already predefined and passed into your jobs by GitLab. And I put that in a build.m file. Now here I am allowed to use the artifacts keyword. So as an artifact, I have the server/spec path, which contains our OpenAPI YAML file. And I add a reports.env, which allows me to export some variables from that pipeline job. Now, I make a slight adjustment to the build client stage we saw earlier by adding some variables, one being the location where I can find the OpenAPI YAML file, one being the project ID I'm currently working in, so that's the project ID of the API, and then the job ID that we just got from the previous step, the export OpenAPI step. And that means I'm all done and dusted in the API repository. So now I can move on to the package repository in GitLab, which is a second repository. And in that repository, I also add a GitLab CI file, and I add a step called build composer client. And if you wanted to, you can add more different types of clients. You could add a TypeScript client or a Java client or a Go client. You can publish as many clients as you want. What that looks like is we have a stage build, and we have a before script, which has a curl command. And that curl command allows us to get the artifact from the job that we defined in the pre-stage of the API repository. It has the CI API v4 URL, which is basically the GitLab UI or the GitLab API URL. Then we have the projects/project ID that we defined. And that means that when I trigger a pipeline job, the variables I used in the upstream are also passed to our downstream job. And then from the artifacts folder, I can get the right OpenAPI specification. And then the command below might seem familiar because we already saw it in our development environment. We have a Java version of the OpenAPI generator command line interface, and we pass it the same flags that we did in our development environment. That means we have the package in the output directory, and the keyword you see as last is the only keyword. And the only keyword has pipelines in there, and that means that this is a specific job that only runs when the downstream pipeline is called. Now, if I wouldn't have any jobs in there called only pipelines, the upstream would fail regardless of me setting the earlier parameter called strategy depend. Even if I have that in there and I don't have any only pipeline specified, it would fail because it can't find the right pipeline to run. So that's the part of getting information from one repository to the second repository. But now we need to use that API to publish our Composer package into GitLab's own Composer registry. And this is what that documentation looks like. It's a post endpoint to the project space with a certain ID. So that's your project ID you can find in GitLab. And then there's either a tag option or a branch option we can give it. And this, what they mean by tag or branch, is the actual tags and branches within the GitLab repository. So that made my life kind of difficult because now I need to manage our code within the GitLab repository through a pipeline. There's also different types of packages that allow you to just post a zip file to an endpoint, give it a certain version. So if I take, for example, the npm repository within GitLab, I can just post my code into that without having to manage the GitLab repository as well. So this is what I ended up doing. I built the package within the package repository, and then I check if it's a merge request or a tag. I can do that by checking the predefined CI variables, which are in there. And then if it's a tag, I'm also going to create a tag in our packages repository. If it's a merge request, I'm going to create a branch in our packages repository. And depending if it's a tag or a branch, we end up with a Composer package with either a valid semver, like v1.0.0, or a dev-branch name version. And we can publish that into the GitLab registry. And this is what that would look like. In our GitLab UI, there's a packages and registry section. And in the package registry, we see that we have two versions of our Composer package, one being 0.1.0 and one being dev-feature/add image API. There's also a container registry I can use for GitLab images, or an infrastructure registry when I'm ready to rock with infrastructure as code. There's one slight downside here, and that is that the GitLab package repository for Composer is not in public availability stage yet. So that's kind of a downside, but there's also alternatives you could use, Artifactory being an example of an alternative. And that means we are done with the package part of our journey. Now there is one part of the journey left, and that's to take a front-end package and add the unit and integration testing in there. So how do we use that package? We first do the command composer config repositories.group ID, and then we pass it in the location of our composer package in our GitLab API. Now that we've linked those up, Composer knows where to look for your packages, and it can do composer require, your package name, and the version like you would any other composer package. Then there's a simple test case for our front end. What I do here is I write a test that gets our homepage, and we check if there is a cat by, and I hope that I can pronounce this correctly, a cat breed by the name of Abyssinian. And if we see that there, we know that we did a successful request to our API and that we can render the page with the information of that API. Now in our front-end GitLab repository, we can run that test. So in the stage quality, we can trigger the front-end client. So this is once we generated the package, we want to trigger another downstream package to our front-end repositories. Imagine if I have a web front-end and an app, we could test both of those. So we do a trigger again, and we don't necessarily want this job to fail because we want to be able to publish our API, release a new or ready a new version, and then allow the front end and mobile apps, for example, to have some time to correct their clients for the new API changes. So that strategy depends. In this case, would be debatable if you would want to have it in there or not. And then in our front-end repository, we have a quality step, which uses PHP 8.1.7, and we run PHP unit. We do that only in the pipelines like we did before, and that means that we have our full setup complete. We have a dev setup, which has a container, which takes an OpenAPI specification, and that OpenAPI specification allows us to generate a package. That package can then be used in our front end so that we don't have to manually enter the URIs of the API endpoints. We don't have to manually handle authorization. We already have some PHP models of what our requests and responses would look like. So we also don't have to do serialization and deserialization. The package handles all of that, which is kind of cool. Once we implement it in the front end, we push our go to GitLab. Once it's in GitLab, there are several pipelines running which generate the package, uses it in the front end, and then we can test the quality of our front end to see if any of the API changes break our front end. And that brings me to the further recommendations part of our presentation. If you want to look at an alternative for the GitLab storage, because GitLab does not offer a space for all of the different types of packages and the different languages that we can generate, you can look at Artifactory. And Artifactory is a bit broader product for storing packages. You can also push Docker images in there. You can then also separate your GitLab environment from your production environment where you would want to use those images, for example. A second recommendation I would like you to look at is Pact. And Pact allows us to do contract testing, which basically means that we have a client, we have a server, and in between there is Pact. And Pact allows a mock server to be created, the front end to do a request to that mock server. It checks if the request is what it would expect. And then the mock server would do a request to a backend. it takes that response and compares it to the expected response. So that means you can test both your front end and your back end to see if they comply with the specification that we defined. Now, there's also a trend of going asynchronous. There's a lot of companies that are starting to use a event-driven kind of architecture. And the OpenApi Spec doesn't really comply with those kinds of architectures. So if you want to go asynchronous, use the async API specification. That allows you to document what kind of messages are going on in your system, what kind of events you can expect, how they're handled, etc. And that brings me to the end of the presentation. I included a link to the actual project in there, so you can have a look at it later. And there's a bit of source code that I left out. For example, some bash scripting that allows me to push the right code into the GitLab package repository. If you have any questions, feel free to contact me through Twitter or my email at DannyVerpoort and hello@dannyverpoort.dev. I do have some time to take questions, and I will be hanging around in Slack for the rest of the day and answer any questions that you might still have for me. And that brings me to handing it back to you, Cal.
Thank you, Danny. That was a great talk. I can't wait to watch that one again because I missed a couple of things. But that was a fascinating piece. Hey, Wim does have a question for you. Does the code generator also cater for paging of API calls in case you have many results, or do you have to do the pagination yourself?
You can define, for example, query parameters that allows you to add a limit and a page. It doesn't by default have that option for you.
Okay. And also, how would you deal with intended breaking changes that would be tagged as a new major version?
Yeah, so a new major version, I would expect to also have a versioning system within the URL. So if the front end is using API/v1, then I would expect the new API call to be API/v2. So that means that the front end won't break yet, and we can have some time to implement our new version 2.
Excellent. Those are the only questions we had, but I'm sure once you pop over into Slack, other people are going to have questions. Hey, thank you so much.